Hello, and you're watching Alien Scientist. Forget all your other standard, regular UFO news channels. Here we talk about real science and we push scientific disclosure. We want unarguable evidence. We don't want grainy videos. We don't want to talk about possibilities of, what if aliens this, what if that. Show me the money. Let's talk about some real shit. So, Carbonado Diamonds. Very interesting. Only found in two places naturally. I think there's another place someone reported that they're found. Brazil, Central African Republic, and in Brazil. And there was an interesting article that goes back. You go here into New York Times in 1996. Here it is. Giant black diamonds of mysterious origin may hail from space. And this was published on September 17th, 96 by William J. Broad. And it talks about the puzzle with these Carbonado diamonds, which are a 11 on the Mohs hardness scale, if you know what that is. Um, the Mohs hardness scale is a scale of mineral hardness that was developed by a geologist trying to. He just came up with a 1 to 10. Diamond's the toughest thing we got, and if anything, 10 scratches 9, 9 scratches 8, 8 scratches 7, all the way down, and it doesn't go up. The softer minerals fall apart and they don't scratch diamond. So the Mohs scale of hardness, or it's a qualitative ordinal scale. If you want to get technical about what kind of scale it is. But it's basically, they found these Carbonado diamonds, and they were actually, they said 10 was the hardest, and then they found Carbonados, and they said, oh, I guess 10 isn't the hardest, we have to make 11 now. And unlike regular diamonds, which are formed in kimberlite, which is a igneous rock, which is kind of like it's kind of like the vent tunnels for volcanoes. Ancient volcanoes had these vent tunnels, and that's kind of where the diamonds are found typically. And they're found in mostly in Africa. There's a couple other deposits in Russia and some other spots, but the Carbonados are really outside of this the major craton. They're outside of the kimberlite zone in this Central African Republic zone. Which is strange for their origins. And there's a theory, if you read the page on these diamonds, on Carbonados, it talks about the extraterrestrial origin hypothesis, and how they think that, this was like part of a supernova, like an interstellar travel like Oumuamua or one of these other objects that smashed into Earth very many years ago. Which is interesting because that Oumuamua, Mao asteroid, right? So yeah, Oumuamua, Oumuamua, Oumuamua. I don't know how to say it. I've heard other people call it Oumuamua. Oumuamua. That's the correct pronunciation. We have a Hawaiian person saying it. Oumuamua. Okay, so we can call it the right thing now. Oumuamua is apparently this the head astronomer from Harvard, Avi Loeb, thinks that has written several papers on this and other objects like this. These interstellar travelers that come to our star and then go to another star, and then go back and forth. They're somehow stuck in an interstellar loop, which is unlike any ordinary space junk. That's all the planets that just orbit the sun, and they don't go and orbit any other suns or any other stars. But this thing's an interstellar, which is really interesting to study. So, anyways. There's a lot of theory that these Carbonado deposits are actually one of these kind of interstellar supernova kind of pieces that crashed into the earth millions, billions of years ago and created those carbonado deposits. So we actually got our hands on some carbonado deposits, and we finally ran some SEM imaging on them, and it was very interesting. We found some we found these metallic wires that what look like little nano wires, and they're made of titanium, which is very interesting and very curious about what they're doing here in pieces of carbonado or carbonado. Here we go with the pronunciations again. In any case, these it's a little different, something a little different, but I have the write-up on this, and I wanted to kind of explain what some of this means. But basically, like the lack of chromium suggests that this wasn't formed in a supernova, because if a supernova created it, we'd find chromium on that spectrograph, right? But we don't see chromium. We see titanium, and we see I think what was the other thing we saw? I have this here. So I don't know. It's worth checking out, and I think there's more study that needs to be done on this carbonado stuff, just from the SEM imaging that we've done, and showing the lack of chromium and the metallic titanium wires in this 2 billion-year-old material. So yeah, we did Raman spectroscopy. No, we didn't do Raman spectroscopy, but we need to do Raman spectroscopy to see if they have sequestered nitrogen. That will determine if they're natural or artificial. We did find acicular titanium powder particles on all the carbonado specimens that we studied. And again, that lack of chromium kind of suggests that they weren't formed in a supernova. So anyways, it's interesting for this for some evidence of, you know, something that was built by some other intelligence, something really advanced. In any case, I want to get back into some of the material science and stuff. Like, these things could be melted down 2 billion-year-old spaceships or pieces of a galactic megastructure, and all these other theories that are floating around about, you know, these interstellar traveling particles and what they are and their origins. If they were part of some massive space station that was blown to bits way back in the day and fell to pieces are still out there floating around in space. Who knows? That would be pretty cool if we could find them, or if some crash to Earth in the near future. This video, I wanted to share this. It's 1 minute and 17 seconds. It's about from the University of it's Chun-Li Guo's lab at University of Rochester. They basically treat these surfaces with just lasers and etch different patterns on them, and they can turn the metal surface black, and it makes it ideal for absorbing solar energy. So some of it radiates out at these other heat and these other wavelengths. That's kind of like the black body radiation. I gotta put my... Oops. I'm sorry if you couldn't read captions of that, but I'm going to post a link to this in the live chat right now so people can check that out. Very, very cool. A minute long video. It talks about what these scientists at the University of Rochester are developing with it in terms of these new age technologies, and what they're able to do with trapping light on these surfaces by means of these surface plasmon polaritons. And it's basically where photonics and electronics meet. This is merger between light and electronics. And this is kind of where it happens in this terahertz frequency domain. There's this gap that we have right now in terms of our sensors and our abilities, and we're closing that gap now at our universities all around the world with this new technology and these ever fine laser etchings, and the ability to take lasers. Um, what Ray Kurzweil predicted in 2014. This ability that we could just take lasers and print things atom by atom in this sort of 3D printer, that atomic 3D printer that would be perfect in every single way. You could print the most perfect things. This is alien technology, in case you guys didn't know. We're learning lots more about metals and how these weird types of geometries and these little tricks of surfaces, polishing the surface and then doing things to the surface, can do weird things. So researchers in the field, they are known as bad metals. But they are really not so bad. As a matter of fact, they're the best superconductors because they are able to conduct current with the highest efficiency without resistance up to high temperatures. This has been seen experimentally, yet their behavior remains a mystery. Hence why they're called bad metals, because they don't behave the way that they should. The parents are like losing their minds. They're like, what kind of child is this? The repulsive forces between the electrons in these materials are much stronger than in low temperature superconductors. So how do particles with the same charge overcome these forces and manage to pair up and to transport current as it happens in traditional superconductors? A team of researchers from CISA, in collaboration with the Vienna University of Technology, have found a possible surprising answer. And these are called Hun's metals. They're another class of these. They're just keeping on and finding new ways that metals are acting weird, including fermionic spin metals. And they have all these. It's all related to particle spins and quantum entanglement, and how quantum entanglement works on the atoms in metal lattices in weird ways, which could explain, another debacle in science that I've been talking about for quite a while. And I say this is all related phenomenon, and this is what happens when there's a big breakthrough in physics or science, is that more and more physicists and more scientists who are on the cutting edge and have different theories, right? Because here's an interesting group study that was recently on physics.org, phys.org, right? Making the best decisions, all right? Math shows diverse thinkers equal better results, right? So that's what I'm doing. I'm being a diverse thinker, and I'm trying to think differently. Everyone in my science, when I told my professor I was looking into cold fusion and I wanted to research cold fusion, after I graduated, I almost put his head between his hands and had a friggin' heart attack, because he's like, no, please don't. That's bullshit, right? That's disinformation. That's not disinformation. That's pseudoscience, right? And I said, no, I don't really. I mean, there's lots of scientists around who have replicated these experiments and are reporting, hey, sometimes we do get results when we're at the right loading level and we have the right, we do the right things, treatment of these metals, we get this weird effect. And these world-class electrochemists, Pons and Fleischmann, weren't, so full of shit when they made those reports of their results, and they did their experiments back in the 80s. So anyways, back to this whole thing, closing the terahertz gap with these technologies, the ability to print in crystals. We're learning way new things about how metals interact with these new types of crystals, new types of interactions. And I'm telling you, people, this is it. Like, all of ufology is I don't pay attention to UFOs or anything that these mainstream people are doing, because they're not talking about the science. They're talking a little. They give you a hint about metamaterials, right? I've been talking about metamaterials for 15 years. This is like 20-year-old stuff. The metamaterials. This is what Ed Fouché first talked about in 1998. Now, like, and I helped like bring that story, about and really as deep into that as I could possibly go. I had direct access to Ed Fouché for years. So, um, we gotta do a video on Ed Fouché coming up soon and metamaterials and talk about all that stuff. Because it's I don't know, it's worth listening to because it's the history. It's what got me into this. Even if it TR3B is a made up lie and everyone who talks about it's a fraud. You know, I don't know. It's still the science. It brought me to like study metamaterials, and the metamaterials brought me to a lot of this stuff. So I don't know. This is like it's drip drip slow, really slow pace disclosure in the mainstream, compared to people what's going on in the scientific realm for people who are really up on it. But again, I'm trying to compile all that information in one place, on alienscientist.com. And I've recently redone the website so that we have some information. We're going to start putting all this information in one spot and saving it all and grabbing stuff that and saving it there, backup copies. Speaking of backup copies, you might want to go and download this, watch this, and download it. If you're share this, this is the one you want to basically. If you want if you want disclosure, I would send out a massive email campaign to all the physicists in your list, and I've been sending this around to all the people in my network. Um, Superconductor is he goes into all the stuff that I've been talking about, going, how the theory goes back to Bryce DeWitt, who worked with John Archibald Wheeler, who worked with Einstein. um, and it's so awesome how so many people are getting this and bringing this information together and really diving deeper than I could, into this, because I talk about this stuff, and then people pick up on it because people are watching this, and they're doing their research, and putting pieces of the puzzle together that I don't even have, but now I have them too, and I'm sharing them with you. Please go watch this. This is all about warp drives and how to engineer these craft. This is all about. This is everything we. Don't share this with the Chinese or the Russians, man. This is just honestly, we're close, man. We're close. We're closer than ever with the material science and the theory. We're going to be able to build these kind of craft within 5 to 10 years, and it's going to change absolutely everything. So this, right? He talked about this article from W Press, right? Oh, guess what? I went and found it. I'm going to post the link in the description right now. Cool. This is what academic sources are key for understanding and learning the real nature of this. Some of this stuff's not easy to understand. Like when I first looked at this stuff as an undergrad student, and I was like, no, I'm more interested in going and watching UFO videos, and this stuff's kind of like this stuff would have been way too out of my league, because I probably wouldn't even be able to get through half of the vocabulary, because a lot of this stuff is stuff you don't talk about with your friends at parties and stuff, unless you go to the kind of parties that I go to, which I don't, not many, but when we do have parties, we talk about all kinds of cool shit like this. So, anyways, Schwarzschild radius, like that's like that was a guy who was a student of Einstein's. He came up with the first solution to Einstein's general relativity theory, his field equations. He came up with the first solution to it, and call it the Schwarzschild radius, which is like the radius of a black hole at which the light can't escape it. So that's what you'd have to know all these what a Schwarzschild radius is, and and a lot of stuff. But anyways, this goes back to like the history of it, and we've traced it back to like not the 60s, late the mid 60s pretty much with that Bryce DeWitt paper was the earliest on the rotating, superconductors, and and then gravitational conductors, right? And figuring out that gap between gravity and electromagnetism, and then realizing that it's like a refractive index, and that if you change this refractive index of light locally, it also can change that gravitational refractive index. And then there's different ways to do it with plasma frequencies, and also these surface plasmon polaritons, which it would explain why these craft have no like obvious components. It's like they probably took this thing apart in 1947 when they Jesse Marcel and all the Air Force stumbled across whatever they picked up at Roswell and whisked away and have been hiding for all these years. It was probably something very similar to these types of nanomaterials and metallic spin metals. But anyways, it could be carbonados because that's what the structure is made of. Like the skeleton made out of like super strong material, and then that metallic glass stuff. If you haven't seen metallic glass yet, metallic glass is super strong, and it is just like that memory foil stuff that was reported at Roswell. So anyways, we are very close to the, I don't understand, man. This needs to be bigger news, and I'm trying to help put it all together for people so that they can get it in an easy, digestible video. And I'm thinking about ending the stream right here at 20 minutes because when I do hour-long streams, it seems like a little bit too much for people, and they just get turned off, whereas a 20-minute video might be a little bit more digestible. So hopefully I dropped enough links and stuff here to keep you busy. And again, this is more stuff on that Roswell case, and this guy Anthony Brigalio has done excellent research into that. Yeah, any questions? I'm gonna hit the live chat real quick. Where am I from? I'm from Rhode Island. Well, I'm from Massachusetts, but I live in Rhode Island now. President Biden release all of the UFO documents and technology? Probably not. It's not for him to release. And honestly, I talking to a lot of the people I've been talking to, I'm not sure how much the government knows themselves. I think like it's a big game that they're playing, like pretending that they know stuff so that they can front to China and Russia that they have this stuff already. When I don't know that I mean there's evidence of UFOs, which is probably the evidence I've seen that we have some kind of technology beyond what people know about. Even most of our experimental planes were UFOs before they were acknowledged, U.S. military aircraft like the SR-71 or the F-117. So there's lots of that. Any questions? I'm not seeing any question. Put a question in all caps and put a question mark at the end of it, and I'll answer your question here before the end of the stream. I always like to engage with my audiences, even if it is 6 in the morning, and the only people that are awake are the insomniacs or the people and my friends over in Europe or other parts of the world. So yeah, make it short and sweet. I don't see any super questions and stuff, but yeah, you can ask Ken Wheeler. Just go to Electric Universe. This guy Ken Wheeler, he knows everything. Yeah, dude. No, I'm not still awake. I woke up early. I wake up at like 4 or 5 in the morning, like every morning, with just thoughts of science and technology, and then I go online and I research all this shit. And I try to put it together, and sometimes I'll do a live stream when it gets to be too much stuff that I have to start closing windows, because it starts getting like this, and I have 3 of those, like, and it gets crazy, and then I gotta take all the best ones and line them up, and then I do it like a dump, where I can show people all this stuff and like, all right, this is what I'm researching this week. This is what you need to look into. Yeah, this is a process optical rectification. It's kind of like how we do it with it's basically like gravity's caused by all these quantum fluctuations that are cumulative. Because I have this whole theory about it, right? So how do you measure a distance, right? What's the most accurate way to measure a distance in physics, right? So measuring a distance, right? Here's a distance formula. We could triangulate. Oh, this is off on a curved surface, right? That's a hyperbolic, in case you didn't know. Um, but this the amount of space between two things or people, right? So how we measure it with the way we like the best way that physicists measured stuff, like how do we measure the distance to the moon measured? All right, so the guy who measured the distance to the moon, right? Um, Let me look up what the hell his name was. Um, yeah, that would be the prize. If anyone who can tell me the guy who did this, right? Look it up, and that will be your homework. All right. So, but the distance is approximately this. But they actually measured it with a laser and a mirror on the moon. They put the mirror on the moon, and then they shone a laser at it and bounced it back to Earth, and they measured the time it took, and then counted the wavelength based on the time. And those counting of the wavelengths they used to determine the distance. So what happens when, the Heisenberg uncertainty principle comes into the effect of that measurement, and you have that uncertainty in the optical resolution of what you're trying to measure? Well, there's a little shift in that distance sometimes. And when there's more photonic interaction like there would be between masses due to black body radiation, that whole effect, natural consequence of all matter just readily receives and radiates light. Oh, black body suit. That's even better. Black body radiation. Not as sexy of curves, but still we're still working with something here. Yeah, so anyways, all masses tend to radiate just regular radiation and bounce stuff off, and heavier masses have more of that. That's why you pick up that's why more massive objects like metals have better heat retention. Like when they sit out in the sun, a seatbelt gets super hot, or it has better what's called thermal mass. Right, thermal mass, and the thermal mass is directly related. It's kind of like this entropy, and it relates through the quantum entanglement of all these photons and how those photons determine distance within the realm of physics. Like physics measures distance by those kinds of things too, and that distance changes over time with change of gravity because of all these cumulative interactions of the optical resolution between these states, and the fact that there's more photonic interaction between you and the Earth than there is with you and the sky. And that photonic interaction, that fuzz and the noise, creates this creates like an optical illusion, which I believe that optical transmission or noise, what's called photon noise, right? I believe that photon noise is very much related to, right, these signals. We get a signal from the Earth, and it's blurred by all this photon noise, right? Because all the gravity experiments where we see like gravitational anomalies, like all the anti-gravity experiments that I've studied, and if you can go to hoverbrothers.com/theory, and you'll find all those. Of all that stuff that I've studied, really, the where the heck is it? Where the heck is the thing I was just on? There it is. Of all the stuff I've studied, all the experiments where we see so-called anti-gravity effects, we also see states where you'd have condensed matter and squeezed states. Where anytime you have beat frequencies or two frequencies overlapped, it can produce the squeezed vacuum state. So that's what we're interested in, is creating squeezed vacuum state. And squeezed vacuum state's important because it lowers that vacuum uncertainty, and it lowers that noise. And if photon indeed has shot noise, like electron noise in cameras, or shot noise, if photons do create that, and there's this optical refining or re-imaging that process that results in what we call gravity, then a way to eliminate that and create anti-gravity would be to resolve that photon and that signal noise and the gravitational noise. Well, that's kind of some of the basics of it, and keep that in mind. Go watch this video and this lecture, and let me know what you guys think. I'm gonna post this. I'm gonna actually copy this to my channel. I think I'm gonna make a backup copy of this video right now. So check it out. Bam. All right, lots of bad videos on warp drive on the internet out there. This one's probably the best one, and he doesn't even mention the words warp drive once. Shut up and donate, fools. We already got a bunch of people donating. Thank you for our anonymous donor that's joined the project to give us a little starting boost. It's definitely helped, and we're gonna get some stuff. We're gonna get some stuff up for you guys soon. We're having these recent videos and these video conferences where we're inviting like these kinds of people on to come and sit and have our discussion group, and we're trying to get more. We're trying to figure out. We just have brainstorming sessions every week about how we can grow this, and to the point where we can create a company that builds craft with all this technology and puts it all together. All right, that's the idea of it. And what's interesting, man, I was pointing out that when you put spheres in a microwave, they tend to resonate and they can create plasma. And I thought that was interesting in terms of some of the information that we've learned about UFOs. So one UFO thing that was news to me. RB7. I gotta make sure I know this. There was a UFO event, and I gotta find this. Oh man! All right, I'm gonna leave this for the next episode because it's gonna take me forever to find this again. Where the hell was it? It's in one of these damn windows. If I don't find it right away, I gotta leave it. Damn it. Nope, it's not on Wikipedia. It was a UFO encounter where 2.3 gigahertz UFO 2.3 gigahertz microwave frequency was recorded by the Air Force. I think it's in Paul Hill's book, the one that the top secret Project Blue Book that NASA conducted parallel to the regular Project Blue Book investigation. But they had a UFO encounter, and I'm trying to find the list of it now, and it was in the 70s. I know that. I think the 60s or 70s. There I go. I know it was in the 70s, and now I think it's in the 60s. In any case, you'll have to look this one up, but it was, I thought it was called the RB70 incident. I have to find this one again. I had it written down, but But anyways, you have to look this one up, and it's a UFO case where they actually recorded the microwave frequency off this craft, and I thought that was interesting. It's like, what if they're using this microwave to create this like they shine it on the craft, and it creates this plasma around the craft, which resonates at this terahertz gap, and You know, you hit it with these beat frequencies so that it calms out all that vacuum noise, and it does it at the, if you do it at the terahertz range, it will do it, you know, for that frequency and everything above, which is everything that matter communicates on, because it's the size and wavelength of, it corresponds to the size of atoms and molecules and matter, and energy. So that if you were to resolve that shot noise in the resolution, that you could basically, yeah, again, different ideas, man. Maybe my idea is not perfect and it's not right, but at least it gets you guys thinking, and it gets people talking about the right things and pointing them in the right directions, because we're almost there, and we're gonna get there. And one of the people that does this and brings real disclosure is going to be one of the people from, I don't even pay attention to these main, like Corbell and Knapp and those people anymore, because I know for a fact that disclosure is coming from one of these groups and one of these people that are going to build this stuff. And you know, this is where disclosure is really going to come from. And this is, you know, it's not going to come, it's not going to come from some government being like, oh, the government's going to release this, or they haven't said nothing about the technology, nothing about the science. So when it comes out, it's going to be someone in within this group and this network that we're building and creating now. So just letting you know. Thanks for watching, and please share this video with the right people, not the wrong people. You can share it with the wrong people too. I don't care. Thanks for watching, guys. And I gotta get to work. Peace out.